to July 2020. Thank you, Nathan. I'll restart. So hello, everyone. Thanks for joining. For those of you who are joining us for the first time, Nathan and I are product managers for Exadata Database Service, Base Database Service, and our multi-cloud solutions. Today, we are so excited to talk about Exadata Exascale. We'll focus on what changes in the storage architecture, where it is available, and why it matters for production databases and developer productivity. I'll cover the presentation part, and Nathan will walk us through some of the live demos he has planned for us on Exadata Exascale in multi-cloud. And while we are doing this, if you have any questions, please post your questions in chat or Q&A panel on Zoom, and then we will try to answer those as we go along. Okay, so a brief safe harbor reminder. Please treat any forward-looking statements which we might mention during this session as subject to change. Now, with that out of the way, here is the headline for today's session. The simple message is Exadata Exascale brings cloud economics and elasticity to the Exadata platform without giving up the database intelligence it relies on, or you rely on. Exadata is known for database intelligent storage, ultra-low latency communications using RDMA, which is remote direct memory access, auto-tiering of the storage at the storage level, that is DRAM, flash, disk, so auto-tiering of that storage. And cloud is known for providing multi-tenant architectures, pooling of infrastructure resources such as compute and storage, and hyperelasticity to meet ever-changing workload demands. Now, Exadata Exascale brings combination of benefits of Exadata platform and the cloud model. So it was just a matter of time to bring it to all the deployment options we have for Exadata, including multi-cloud, that is in Microsoft Azure and Google Cloud. Also, it is soon coming to AWS as well. Now, to see why that is meaningful, let's first look at the familiar ASM model. This is the proven Exadata architecture all of us know. ASM instance runs in each VM cluster. Cell disks from the storage servers are carved into grid disks and presented to ASM. And those grid disks are part of the disk groups such as data, reco, spares, which you can see on the screen here. And those disk groups are dedicated to an individual VM cluster. It delivers all the Exadata smart features such as smart scan, storage indexes, smart flash cache, columnar caching, Bloom filters, etc. The operational consideration is capacity reallocation. When multiple disk groups or clusters need a different allocation, the grid disk need to be resized and rebalanced. It works very well, but the unit of management is closely coupled with the VM cluster. So what did we do for that? We have Exadata Exascale. Now, Exascale keeps the Exadata intelligence, but changes where that storage management responsibility lives. With Exascale, storage management moves from the database clusters into Exascale services running on the storage servers. Those services manage pools, vaults, volumes, and then protection for the data on those volumes, caching and tiering, metadata management, snapshots, and also the clones. For Oracle AI Database 26 AI, Exascale Smart Storage is natively supported and enables direct I/O and RDMA, which is remote direct memory access, as I said earlier, for those operations. Importantly, the Exadata Smart Storage features or capabilities, they remain available on the Exascale Smart Storage as well. The practical payoff is that adding storage capacity becomes a lightweight metadata operation rather than a cluster by cluster reshaping exercise. That is the architectural foundation for granular elastic consumption. Now, let's find out where can we use Exascale architecture in the available infrastructure choices we have in multi-cloud. Now, for Exadata Database Service, we have two choices which are shown here: dedicated infrastructure and we have Exascale infrastructure. Dedicated infrastructure, as the name suggests, gives complete server and tenant isolation, starts at larger scale, and is designed for biggest transaction processing, analytics, and consolidation workloads. On the other hand, Exascale infrastructure is the shared cloud-style option. It starts with single node VM cluster, 80 CPUs, and 300 gigabytes of Exadata storage, then scales granularly from pooled resources. The decision is not about compromising on Exadata capabilities. Both options retain the Exadata performance, reliability, availability, and security. The decision is mainly about isolation model or consolidation, low cost entry point, elasticity, and the operational benefits such as instant thin clones, which we will look at in a bit. Now, we'll just look at the dedicated infrastructure first, if we can enable Exascale storage there or not. So the answer is yes, as you can see on the screen. In the dedicated infrastructure, you can use the proven ASM architecture for both 19C and 26 AI databases, or you can enable Exascale storage for your 26 AI databases. Exascale storage is available for Exadata Database Service on dedicated infrastructure in OCI and in multi-cloud, specifically Azure and Google Cloud. It is supported on X8M and later with the required 26 AI and 26 AI database and grid infrastructure, plus the Exadata system software image has to be 25.1 and later. Now, a reassuring point for existing environments. ASM and Exascale can coexist on the same infrastructure. Database 19C can continue using ASM, while 26 AI can use either ASM or Exascale. That means the adoption path can be incremental. Existing database and storage servers can be used to provision Exascale storage and Exascale VM clusters while retaining workloads that remain on ASM. For Exadata Database Service on Exascale infrastructure, you can run 19C and 26 AI databases as well. For 19C, ASM can sit on top of Exascale block storage using Exascale direct volumes or EDVs. You will hear that term a lot, and when you are reading the documentation, you'll see that a lot. This preserves the familiar ASM disk group experience while gaining the Exascale block storage layer underneath. For 26 AI, the architecture can use Exascale Smart Storage directly. Both paths use low latency RDMA, which is remote direct memory access, and the Exascale volume layer manages striping and mirroring. So in short, 19C with ASM uses EDV-backed block storage. 26 AI can use the full Exascale Smart Storage experience. Now, here is the same message, which we have seen for the last couple of slides, but condensed into the multi-cloud service metrics. This matrix is the quick reference for you. On dedicated infrastructure, Exadata Database Service on dedicated infrastructure, 19C uses ASM, and 26 AI can use ASM or Exascale Smart Storage. On Exascale infrastructure, that is Exadata Database Service on Exascale infrastructure, 19C uses ASM on EDV-backed Exascale block storage, while 26 AI uses Exascale Smart Storage. The key takeaway is that the 26 AI path unlocks the native smart storage model, while 19C has a supported bridge through ASM and Exascale direct volumes. Now, let's zoom more into the Exadata Database Service on Exascale infrastructure service itself. Exascale infrastructure is designed for a low-cost entry point because you provision a VM cluster and database storage rather than a dedicated physical infrastructure. Compute and storage scale independently and granularly from a shared Exascale compute and storage pools. So you pay for the resources you actually need. The slide shows the current sizing range from a single node VM cluster with 8 total eCPUs and 300 gigabytes of vault storage up to 10 node VM clusters with 200 total eCPUs per VM and 100 terabytes of vault storage per VM cluster. That is especially relevant for workloads that need Exadata characteristics, but do not want to begin at a full dedicated system footprint. Now, this one shows the building blocks of Exadata Database Service on Exascale infrastructure. Think of the services comprised of two logical resource pools using the data-optimized multi-tenant Exadata platform, Exascale Compute Cloud and Exascale Storage Cloud. You create VM clusters, which are provisioned on Exascale Compute Cloud using underlying physical database servers. Each cluster gets its VM storage from Oracle managed shared storage. Database files, those live in logical storage vaults as shown in the picture, and the vault data is triple mirrored across the Exascale Storage Cloud for redundancy. This is why the model can be both isolated at the logical resource level and elastic at the infrastructure level. VM clusters and vaults are the core building blocks you work with. As a customer, you go and provision VM clusters and the database storage you need for your database. Once those building blocks are in place, elasticity becomes very, very practical. Starting with compute. Let's look at compute. Now, Exascale separates enabled eCPUs from reserved eCPUs. So when you are creating VM cluster, you can define these enabled eCPUs, reserved eCPUs, and the sum of those two is the total eCPUs for your VM cluster. You can enable reserved eCPUs online through the console or API without rebooting the VMs of your VM cluster. Increasing the total eCPU allocation is different. That requires a rolling reboot. Now, available VM memory is tied to total eCPUs, that is at 2.75 gigabytes per eCPU. Now, one commercial nuance there, database licensing applies to enabled eCPUs, not to the total eCPUs, while infrastructure cost applies to total eCPUs, including the reserved capacity. The other major agility story is clones and snapshots, especially for developers and testers. Now, this is one of the most compelling application level benefits. With Oracle AI Database 26 AI on Exascale infrastructure, teams can create PDB clones for development or test from a live PDB or an existing snapshot. The clone can be a full clone or a thin clone, and it can be created across CDBs and VM clusters. Now, for thin clones, the story gets better. Exascale uses redirect on write technology. What that means is the clone initially shares blocks with its parents. Only changed blocks consume additional space. So as and when there is a change to a block, that block is written separately. And that's called the redirect on write technology. In practical terms, that gives you a writable point-in-time copy without immediately duplicating all of the data. So that creates your space-efficient clones. That means the result is fast, instant, space-efficient copies without the older operational prerequisite which we had of having a read-only test master. That changes the developer conversation from how many copies can we afford to how quickly can each team get a realistic copy. Now, snapshots are the consistency point that makes these clones workflows even more powerful. Let's look at snapshots. Now, a snapshot is a consistent point-in-time view of a pluggable database. From it, you can create a thin clone quickly and space efficiently. Now, you can look at this for three clear use cases. One could be reviewing data as it existed at a specific point in time. The other could be you want to restore that data to undo unwanted changes which has happened to the database, and give each developer or test team a point-in-time database without making a full physical copy. At the exascale file level, snapshots are read-only and thinly provisioned. So the snapshots are also thinly provisioned, similar to the clones. And clones are writable. Both rely on redirect on write techniques. So the visual is showing a repeatable operational pattern. Take a consistent point, preserve it, and branch a thin copy exactly when the business or engineering team needs it. All right. Now, with this foundation, I would like to turn it over to Nathan to show us some live action for Exascale in multi-cloud, and also share with us what's new in Oracle multi-cloud since our last session. Nathan, over to you.
All right, Vishal, can you see my screen?
Yes, I can.
All right. Cool. So for today's demo, I'm going to be operating in the Azure portal, and I've got, I don't know, 4 or 5 things that I want to show you really quickly. So I'm just going to show here we're already into the Oracle AI database at Azure. Part of the portal, you can see the available services, Autonomous AI Database, the 2 Exadata Database Services, one on dedicated infrastructure, the other on Exascale, also base database service. So before I get into the Exascale portion, I'm just going to show you how easy it is to deploy an Exadata database on dedicated infrastructure, that infrastructure itself. So you can see we've already got one created, but say I'm interested in creating another infrastructure resource. So I'm going to have to define or specify a resource group for that. I'll have to specify a name. I'm going to specify a region. And because these are physical infrastructure resources, I'm going to specify which availability zone that this is going to be deployed in. And that may be a little counterintuitive for some folks who are more cloud native, but you're thinking about this. This is a physical resource. It resides in an availability zone, and that's where those logical resources are then going to be deployed on top of the physical infrastructure. Excuse me. Now, here I can choose what Exadata infrastructure model. Today, in this particular region and availability zone, I have access to the X9M-2 and the X11M. And so I'm going to specify, well, I've chosen a poor region and availability zone because these servers don't have availability right now. But just to show you how simple it is, after I choose my infrastructure model and that database server type, I can then scale the number of database servers and as well as the storage servers to whatever I need. And so the minimum configuration is 2 database servers, 3 storage servers, all the way up to 32 database servers and 64 database servers. And then I can specify a rolling or non-rolling maintenance method. So one, if I want rolling updates, then each virtual machine, each server in the cluster will be updated in a rolling fashion. Otherwise, I can do a non-rolling and say I want to take the shortest downtime possible, but everything be offline and updated at the same time. I can enter some context, give my consent to the terms of the service. I can apply tags and then review and create. And of course, I've not supplied enough information for this to actually create. And it's telling me that, so I'm going to cancel out of this. But let's just go into our existing infrastructure, dedicated infrastructure, and you can see that this one is comprised of 2 DB servers and 3 storage servers, and it tells us how many total OCPUs we have available, as well as total on the infrastructure itself, and as well as our total storage and storage available, and what's allocated to ASM today, as well as what's allocated to Exascale. Now, as Vishal was talking about, with a dedicated infrastructure, we can configure Exascale storage. And when I do that initially, that will initiate a rolling reboot of the servers across the cluster. Thereafter, configuring Exascale storage just allows me to adjust the total capacity that's available for Exascale. And so that's a soft update. And that just defines the maximum capacity that can be allocated and distributed across Exascale vaults on this infrastructure. And so it's really simple to administer your Exascale storage on a dedicated infrastructure as well. All right, now let's go over to our Exascale infrastructure resources. And as you can see, we've already got quite a few virtual machine clusters created on Exascale infrastructure, but let's just walk through the create dialog for that as well. Now, say I'm going to specify a resource group. I'll have to give the cluster a name. Again, I'm going to choose the region and availability zone. I have the option to specify either license included or BYOL, and I can change this later at any time. I can also specify the time zone. Here's where we get to the storage type that Vishal was talking about. So by default, we're going to present an Exascale Smart Storage vault for this VM cluster. And for that, our only option is 26AI database. Now, say I choose to present an Exascale block storage vault. In that case, we default to the 19C grid infrastructure, anticipating that we're creating 19C databases on this. One other difference that you'll notice here is down below, when I have Exascale Smart Storage selected, I have the option to do storage auto scaling. And you can see I'm starting out with the smallest amount of storage possible, which is 300 gigabytes. And I can set my auto scaling limit to, say, let's go 1 TB. So with the smart storage vault, I get auto scaling. And you'll see that option goes away if I select the block storage. One more thing, so I can create a new vault or I can select an existing vault. I don't know that I have any in this particular AZ. I don't. So let's go, and I would give the vault a name, again, specifying the capacity. One other option that I have in creating my Exascale VM cluster is the ability to add additional smart flash and memory cache to this configuration. So to be clear, you get smart flash cache and XRMM cache on that storage server by default. This is adding additional smart flash cache and XRMM, and you specify that as a percentage of the existing capacity. So say instead I say 40%, that means I'm adding an additional 120 gigabytes of smart flash cache to this particular VM cluster. I'll need to specify an SSH key pair and download that, but let's just look at the rest of the configuration. Notice that it defaults to 2 VMs in the cluster, assuming that we want high availability, but I can go as low as 1 or as high as 10. If I say 11, it's going to bark at me. And now we get to the configuration that Vishal described, where we have the enabled eCPUs per virtual machine versus the total eCPUs that are available on the cluster. So by default, I'm not reserving any additional eCPUs. However, I have that option here. And so if I select that, this stays the same. I still have the same number of enabled eCPUs across the cluster, but let's say I want total eCPUs per, let's say 24. Here we go. Total eCPUs across the cluster. So right now I have 16 enabled. say that I want an additional 8 per, come on. There we go. Total eCPUs per VM. Say I want 24. Now I have a total of 48 eCPUs across the cluster, and you'll notice that the amount of RAM that I get available on my cluster is a function of that total eCPUs. So the formula that Vishal described, that 2.75 gigabytes per eCPU applies, and I get access to that RAM regardless of whether these eCPUs are in the enabled or the reserved state. And then I can also adjust the amount of file system storage capacity per virtual machine. So at a minimum, I have 280 gigabytes. That can scale up to 1100. And so this number then reflects the total amount across that VM cluster. And I'm going to speed it up here. We do have to specify a virtual network for this resource to reside in. And then this client subnet box will populate with a delegated subnet that we've created and defined for the service. And beyond that, we're looking at diagnostics, consent tags, and review and create. So that's all there is to defining your Exascale VM cluster. Now let's take a look at this particular Exascale VM cluster. This one resides in Australia East, Zone 3. You'll notice that it has 8 eCPUs in reserve, while it has 16 eCPUs. So this is across the cluster again. Now let's go take a look at this. And it's using a smart storage vault, Exascale smart storage vault. Now let's go take a look at this one in the OCI console. And here we can see the same information, right? 16 enabled eCPUs, 8 reserved. Now, say I want to take advantage of those 8 reserved eCPUs. Now, say I have these available, so I could actually scale this up to 12 eCPUs per VM right now. Click that button, and this will happen online over the course of a couple of minutes, and those eCPUs will suddenly be available. But say I decide I need to increase the number of eCPUs greater than what I've allocated in both enabled and reserved. Now, if I tell it to scale, I'm going to get a warning because this requires changing the total number of eCPUs, and that's going to require a rolling VM reboot. Again, if I were to scale just within what's already allocated and reserved, click this button, that's going to happen online. I don't want to do that just yet. So let's go take a look instead at our container databases. And I've got 2 container databases on this particular VM cluster. I'm going to choose this one, and you'll notice that I've got a couple of pluggable databases here. And this PDB1 was the default PDB created when I created this VM cluster, and the container database, I've already taken one snapshot. So I can notice that I can clone from that snapshot. I can also create another snapshot. So let's say demo 2. Go create. So while that's creating, let's go back and look at the other. This is a PDB that I've already cloned. You can tell by the name, but that at this point, that's really all you can tell by, is that once that database has been cloned, whether it's a thin clone, a thick clone, you really can't even tell anymore. Exascale just obfuscates all of that from you, and it's really not relevant anymore. This cloned PDB now looks and behaves exactly like any other PDB on the VM cluster. And you can see that I've already taken one snapshot of this PDB. I can also clone from this snapshot, right? So this in effect creates nested clones. But I could also instead just look at this PDB and clone in real time. So if I want to have a snapshot to refer back to, or perhaps create additional clones from that exact point in time, it makes sense to take a snapshot. Otherwise, I can just clone at a moment's notice and have that clone available as an additional PDB on my VM cluster. And that's it for the demo. Now let me share slides, and I'm going to hurry through this. Um, so, we talked about multi-cloud. When we're talking about multi-cloud, we're talking about running Oracle Cloud infrastructure inside Azure, Google Cloud, and AWS data centers, and having those Oracle database services available to those hyperscaler partner customers through the hyperscaler marketplace. But we physically co-located those infrastructure resources to give ultra low latency between the hyperscaler application services and our database services. We've also integrated, as you've seen, into that hyperscaler's portal and APIs so that you can manage and monitor the Oracle Cloud infrastructure resources from that partner hyperscaler's ecosystem. We do want to talk about a recent launch, which is the new Exadata X11MV database and storage servers. The V stands for virtualization. And as you can see here, this is the latest generation of hardware. It's really geared for greater consolidation with twice the file system space per VM to store additional database homes. It also provides capacity for up to 12 VMs per database server instead of the 8 VMs for the X11M and previous versions. And it enables up to 24 VM clusters per infrastructure, again, up from 8 for the X11M and previous. So we had a lot of customer requests to increase the number of databases, the number of virtual machines, and the number of VM clusters possible per dedicated infrastructure. And the X11MV is the answer for significantly enhanced database consolidation. And that X11MV is already available in OCI and multi-cloud regions, and the price is the same as the X11M. So we really expect customers to start consolidating to a greater degree as they transition to this new offering. Now, here's the Oracle Multi-Cloud Service Availability Matrix as of this month. The big news recently is that Autonomous AI Database Serverless went generally available on Oracle AI Database at AWS in June. And we announced this month that Exadata Database Service on Exascale infrastructure is coming soon to AWS. That's why you see this planned value here under AWS. You can read more about that upcoming launch at the first link in the resources slide that I'll show in just a minute. Here's a full accounting of the available partner hyperscaler regions for Oracle Multi-Cloud. Just in the last month, we launched 2 additional regions for Oracle AI Database at AWS, including US West 1, North California, and Europe North 1, Stockholm. This actually fills out our announced region rollout list for Oracle AI Database at AWS that began with 2 regions literally 1 year ago. Now we still have 2 additional announced regions coming for Oracle AI Database at Google Cloud, as you can see here. And we're also deploying additional availability zones in existing regions. And so if you have any questions about exactly what's available in terms of AZs launched within a region, please refer to the link at the bottom of this slide or view the Oracle documentation and the What's New announcements. And if you're waiting for planned regions shown here or need additional AZs beyond what's already live in an existing region, just please reach out to your Oracle account team or reach out to us directly. As always, we put together a little late night reading list for you here, including several blogs on Exascale technology, as well as the Exascale infrastructure offering. There's also a link to the OCI service documentation and the instructions for provisioning Exascale storage on the Exadata Database Service on dedicated infrastructure in both Azure and in Google Cloud. And these links will be available in the deck that we post on Ask Tom after the session. One little plug here, watch any of our previous episodes covering this broad range of Oracle multi-cloud topics using the QR code here or just by visiting YouTube and searching the Oracle Database Product Management channel, or maybe just search multi-cloud happenings. We will get this episode posted there as soon as possible. It usually takes us a day or two. And now I'm going to open it back up for Q&A. Vishal, do we have any outstanding questions?
I see this one coming just now. So it's from Satinder. Instead of using the Google File Store, customer has option to use ACFS in case of 19C. Is the understanding correct? Um, I, I see that the ACFS use on Exascale volumes. There's a blog as well on that. If you search for that, you'll probably find it on Google. But there's a blog on how you can use the Exascale volumes to create the ACFS file system and share it across the VMs in your VM cluster. So yes, the answer is yes for even for 19C.
Awesome. Thanks,
Okay.
Vishal.
I don't see any other outstanding questions. We were able to answer those questions on the chat itself.
All right. Well, it's almost 40 minutes in, so I think we'll wrap up here. I'm going to stop recording.